Hi guys, welcome to episode 1 of our Kangaroo Flat Hybrid Home series. I'm David Millard from EcoWise Homes, and this is...
And I'm Anthony from Outlier. Look, this is another hybrid home collaboration with David and the team at EcoWise, and we're really looking forward to being able to show you what we've done differently in this project to achieve the high performance outcomes, because as we know, every single project requires a bit of a unique approach to how to best achieve the outcome we're looking for. So where do we want to start?
Well, let's start off probably early on the design stage, that sort of thing. So tell me, Anthony, how does the structural engineer determine what sort of slab to design for a home?
Okay, so it always starts with getting the soil tested. Now, what they've done here is they've arrived on site with a drill that sits on the back of a ute or a trailer, and they're drilling down into the ground to bring up what is found. I think they go down around about 3 metres or just over 3 metres.
Yep.
And from that, they're able to check that core sample and tell us exactly what the soil type is. Now, the particular soil type here didn't actually reflect the outcome of what we received as the result of the soil classification, which in turn we actually designed our concrete structural slab and piers on. But because of the proximity to the trees here, we've got root systems that are invasive, and that's now bumped it up to, I believe, a Class P.
Yep.
And that's what, we've
and
designed
I do
it on.
believe there was evidence of existing tree roots and that from existing trees which were removed well and truly before we were involved, so at some stage along the line. So that sort of added to that reasoning for a P classification, so problem classification.
It did,
So since then, the engineer sort of recommended, and we sort of felt with this site too, a waffle pod would be a good option. We will chat a bit more about the waffle details and that later on. But this is what we call a cut and fill site. So there's a bit of fall from this top corner up here to our lower corner down here. So the excavators come in at the start, and we actually, which Outlier, Anthony from his team Outlier, have determined what sort of cut depth we need to do. So it sort of works out that we cut in the top corner and sort of push all the fill down. As Anthony said, the geotech engineer come out to tell us, where a good founding depth is. So we found a good siltstone base at probably about 700 deep. But in the cut corner, we don't have to dig as deep because we're already excavated a little bit. But then in our fill corner, our bored piers go to sort of down to about 2.2 metres and that sort of thing.
Yeah.
And don't worry about a house being built on the fill, because our concrete piers penetrate the fill and get down that siltstone base.
Yeah, I mean, we're really fortunate that we're able to use software that has this modelled element to it. So from information that we're given from our land surveyors on what the heights and everything are doing on site, we can incorporate that into our software and actually have a look at how this will be in real life. So we're able to determine that site and cut from that. The other thing that I'll mention is the site does have a bushfire management overlay on it. So we do have, again, what is declared as a woodland behind us, and that resulted in what is known as a BAL, or bushfire attack level 29. So the home has been constructed to ensure that it's protected from embers, because as we know, around 90% of the homes lost in the Victorian fires, Black Saturday, that was due to ember. So we've been able to detail the home as well to be bushfire resilient. Further to that, we also have a few constraints on site that we've designed to. And you'll notice the angle of the home behind me, and we'll get into that in a bit further, but there's actually a swale drain, which is a formed easement on title that runs right along the front of the home here. So I know we love a good constraint when it comes to easements and unused government roads, so I'm sure those who have watched our previous episodes are on board with that. So we're in one of our favourite poses when we like to talk about slab details.
Details, we love it. Good stuff.
David, can you please walk me through the layers that we've got on this particular project? Yep. Some are familiar that everyone's pretty aware of, but yeah, maybe there's a few other bits and pieces here that's worth mentioning.
So I'll just point out to the audience that is not aware that all these timber you see here, that's called formwork or boxing. So that's all set up. We spend whatever time it takes to set it all up, but that's only just a temporary structure.
Yeah.
So that way we can form the concrete and we know it's going to be in the exact size and location that we're required to be. To actually break it down further to the building parts that actually remain here permanently. So this is our builder's plastic. So that's a plastic to protect any moisture coming up from the ground, and then soaking into our slab, and then further rusting this structural steel that you see here. Then even worse, rotting away our bottom plates over a long period of time. So
it's a vapor barrier.
That's right. Yep. And one thing I really am big on is obviously, you know, creating homes that last for a long time and that sort of thing. And one thing really big on me is this building wrap running up the side of my slab. So later on, this dirt will get filled in sort of approximately around this height here, and we want this plastic to stay there, just create that barrier. Further, you can see here we have our 50mm XPS that goes up the side of the brick rebate.
Yep.
Again, so that's thermally breaks it from the ground.
Here's one you prepared earlier.
Sample there.
So, yeah, I know a few people have watched our previous videos, would be quite familiar with the 50mm XPS, but for those who can't see, that's tucked in behind the red board here.
Yep. And that actually continues all the way underneath the waffle pods. So yeah, again, this slab's fully uncoupled. There's no connection, and as you know, the sensors in another project we've done in Castle Main shows, what would you say it gets down to in the middle of winter?
Yeah, I think the lowest reading we had in our ground temperature sensors was 6 degrees.
Yeah, so it's obviously adds a lot of benefit in the middle of winter. In
absolutely, but it certainly spends a good deal of its time below 10 degrees during those really cold months of the year. So.
Yeah, and you can imagine 10 degrees constantly soaking up into a 25 degree or 20 degree inside temperature.
Absolutely, absolutely. That ground's going to be leaching the heat out of that thermal mass of the slab, you know, and that's we've just completely reduced that by introducing this insulation board as a thermal break.
Yeah, for sure. And you can see we've got one last final piece of XPS foam installed on the brick rebate here. So we try and do that before we pour. It's just one less step and that sort of thing to do later on. So how that gets installed is with these shark tooth screws. They're 125mm batten screw, but you can actually see they've got a larger coarse thread on them.
Yeah. And
they work in really well with these plastic washers that get put on the inside. The screw goes through it, but then later on, once we pour the concrete, these screws will get stripped out to get reused in the next job. And then to stop this XPS foam from getting pulled out, we just use nails or screws. Every so often they just sort of get put in on an angle, and it stops that XPS from falling away later on.
Yeah, great. I know that was one of the questions we've been asked a few times by watchers. So. The other thing that those with a keen eye will note is that there's an extremely tight mesh setting on this particular project. So these are at 100 by 100 instead of your typical 200 by 200. I'm sure to, you know, the displeasure of those who have had to install it.
Yep.
But you know, the reason for this is it's increased the tensile strength of the slab. It's been able to then span those between the pier supports that are on this project.
And again, I think being a burnished slab, so a finished slab you're going to see, it's important that we want to minimise cracking.
Absolutely, we'll assist in that for sure.
Yeah.
We also have all the underslab plumbing done now as well. So we can see the typical collar ties around the plumbing that's for termite protection.
Yep.
So what do we, as always, Central Victoria, and I'm sure other places for those who are watching, we must pay a huge amount of attention towards protecting the home from termite infestation or borer infestation. So what have you done on this particular project? Will be the standard physical barrier, is there anything additional?
Yep, so we've got a standard physical barrier that's a sheet and it goes underneath our air seal plate. Any plumbing penetration or any slab penetration, you can see down further we do have where the power comes in. We've just got sheeting on that. So, and then the other thing is we use is termite treated timber.
Yeah, so a couple of layers of protection.
Yeah, for me it's about, a client's investing a large amount of dollars in the home. We want to go those extra steps to ensure that, that it doesn't have issues further on.
Great.
So, again, building to last longer.
Yeah, look, I reckon we might walk a bit further around, have a look at some of the influences the site constraints have had on the design, and maybe a little bit more of a look at the site cut and fill as well for those interested.
Yep. So we're currently standing in what will be the alfresco area. Anthony, would you like to explain to me a bit about the design of this project and how it's all been created?
Yeah, absolutely. So I personally love it when we've got lots of constraints to work with in a design. It gives us that ability to be able to push it to the limits, so to speak. So as I mentioned, directly in front of us, running along the front of the home on an angle is an easement. And now we've built right to that. And that is where you'll see that the angle of the home starts to begin. So we've been able to set the home back at that end, but once we get to here to maximise the footprint of the home, we've then followed the line of the easement. So that's why we have these angles.
Yep.
Well, also, directly in front of us, or just to the side I should say, is north.
Yep.
So we're trying to maximise as much of that northern solar gain into the home as we can, whilst also having that play-off of knowing we're going to have an adjoining neighbour only 3 to 4 metres away on my left. So we're trying to create visual barriers, we're trying to get solar gain into the home, but we're also trying to provide adequate effective shading overhead, because we can use horizontal shading here, being it's orientated to the north.
Yep.
So to my right, we're using awnings over the window, but here we've got the al fresco roof running over us, which also follows on the angle as well, to try and have that play off of shading versus allowing solar gain in, whilst also having privacy. It also protects us a little bit from the weather patterns that exist in this area, particularly in this site here. We've got a bit of a valley that comes up through the tree line, and we've got a huge amount of overshadowing. As behind me, or in front of me I should say, is a large woodland area. The predominant tree height I believe was anywhere from 15 to 20 metres. So we've also got it a step back as far as we can, further up on the right of me here, to maximise on that solar gain and, you know, reduce that shading impact that's going to occur on the site from time to time of the year.
Yep.
There's only a few other bits and pieces to discuss. The material palette was actually inspired by the ironbark forest, the forest, the woodland that I've just described. So we've got a lot of touches of charred timber. We've got a little bit of bare stone as well, and you know, brickwork as a bit of a combat to the Bell 29 bushfire requirements as well for construction.
Cool.
Yeah.
Very good.
I should also mention that we've also got double glazed UPVC, thermally broken UPVC windows throughout as well.
Yep.
Yeah. So one of the things that's been really helpful for you know, myself as a designer is actually getting on site and seeing how accurate that model of the site cut and fill was compared to what, you know, has actually been done. And look, honestly, it's very close, and you know, that's great for me, and I know that, you know, moving forward that we can you know, work these things out as early as possible. So right now we've got, oh, gosh, I don't know, what would that be there, about 700 or 800 millimetres of fill?
Yeah, I'd say about 700. Yeah.
And we've got about 400 of cut, sorry, probably about the same, 700 or so of cut up the corner there. So what we look for when we're designing is about a 50-50 site cut fill. So if you were to cast your eyes across the whole slab now, you'll kind of see that perfect line where the cut and the fill meets about halfway along the slab. And that traverses across and to the other side of the home's like footprint as well. So we've got that perfect sort of taking out, cutting 50%, and then pulling that out and creating that other sort of 50% of fill. So it's trying to work with what we have on site and not trying to bring in too much extra fill or take it away.
Yeah, no, I think by the time, well, there's a bit of excess soil here at the moment, but the time we actually backfill around this slab and we've got a portion up near the driveway that needs to be filled in, it's going to work out pretty good. But I'll just explain to you a little bit about the process of the actual cut and that sort of thing. So as Anthony said, we have a cut line, that anything that side over it, that's a cut, and then the fill line is on the other side. So as the excavator's moving his dirt down to the fill part, he's actually rolling it in and trying to compact it. So it's actually classified as control filled. Anything over 800 mil is technically called uncontrolled fill. But yeah, so it's all sort of controlled fill. It is trying to get compacted, but as we said, don't stress about your house being built on fill, because we have our board piers going down that sandstone base.
Yeah. Now, our geotechnical engineer's report tells us all this in detail, gives us the instructions of what we need to do. So
for sure.
1, 2, 3.
So one of the things that we're always trying to be mindful of when it comes to the hybrid home method is affordability. Now, that means sometimes a little bit more leniency when it comes to thermal bridging, or different approaches that may be more just, I don't know, providing a bit of ease of constructability or methodology. So rather than having a complete break in the slab here and having to come back at a later date and pour the slab to the garage, we've provided a step down. What exactly have you done here, David? And how have you approached it?
Yeah, so we've got a 90mm step down here, as you can see, that yellow bit of formwork. That will have a piece of XPS eventually put on the 90mm strip there on the other side of the concrete slab there. So And then a wall frame will sit on top of that, concrete slab and XPS. Again,
Yep.
it's a similar detail to our external walls. We have a 140 wide wall,
Yeah.
50mm XPS, that gives us 90mm bearing capacity. So you do only have like a small strip across here, like the thickness of the concrete slab, which is 100mm. That's, is that a thermal bridge net. And I think it's really important, as you just touched on, about making things relatively cost effective, that, we could do, fully thermally broken slab, but it does come at a price point. Another thing is to consider that this concrete slab for the garage does actually have XPS underneath it, and the same with the edges and that sort of thing. So, yeah.
Now, it is a 140 stud, so that will be sitting flush with the outside of the XPS, and that's also because we wanted to provide that 140 or that R4 of insulation to separate the garage from the house, so that performs that a little bit better as well.
Yep.
Now, one of the things that we have spoken about, and I believe that we've come to agreement, I think, and it was probably your research that's led this on, is to move away from the EPS waffle pods. They're on this project, but moving forward, we've got an alternative product that we're looking to use.
It's something that's obviously we want to build homes that are sustainable and use sustainable products and that sort of thing. It's probably in the research stage at the moment, so I can't say too much more. But we're definitely looking for different options. That's the thing. Waffle pods are cost effective and that's the thing. But we've got a lot more to keep in mind.
So anyone listening, watching, if you've had some success with some alternatives for void formers, reach out and let us know. So I wanted to explain in a little bit more detail why we used a waffle pod void former slab system and not the typical raft that we did on the previous projects. Now, when we had the concept engineering prepared on this project, we had a bunch of internal beams. Now, if we envision that this waffle pod here is our internal concrete beam, every single one of them in the method we used previously needs to be wrapped in XPS. So if I just flip that upside down, try not to get that there. Thank you, sir. That is now the bottom of our concrete beam and needs XPS underneath it, and we need it on the sides as well. So when it comes to a waffle pod, what we'll do instead is lay our XPS flat along the entire floor or ground of the slab, and then we just come along and just plonk our waffle pods on top of it like this, rather than having to wrap each one individually. So that allows us to do it a lot quicker. But the playoff, I guess, is there's a little bit extra steel work that needs to be installed and tied off in between.
I think I'll just add to that too, is as we explained, we've got the concrete piers that have been bored down to our sand base. If we were going to go down the avenue of a raft slab here, everywhere that we've got external beams and internal beams, we'd have to excavate down to the sort of that 1700 depth to get that sand base, and then backfill or pour when we go down deeper past that bottom of the actual concrete slab, fill that full of blinding concrete, which is a lower strength concrete that just fills up that void. So again, that's just large volumes of concrete. So we're just trying to avoid that sort of thing with it. So
And look, as we mentioned earlier, every project requires its own solutions. This is the one we had on this particular project, but then of course, as we mentioned, we're very much looking into alternatives to using the APS waffle pod system.
So I think it's important, every soil classification, but then every site's unique and different. So there's just case to case basis, I think, with slab design, and the same with you with your house design.
And we're able to ascertain what that is very early on in the design process. Typically, this is what you would expect during the construction phase. We're in concept design when we're having these discussions in a collaborative environment with our structural engineer and geotechnical engineer.
Again, it's getting that team together.
That's it.
Thank you for watching the episode. Please reach out to me if you have any questions.
Please come and like and subscribe to our YouTube channels. The support allows us to keep doing this. We do have a Patreon now, so if you feel like financially supporting us as well to produce even more content off-site as well, we'd appreciate that. But otherwise, I hope you enjoyed the first episode of our Kangaroo flat hybrid home, and we've got a few more episodes to come, so follow along.
Stay tuned, guys.
Hey.